Ladies and gentlemen, we are looking at note 6.2, which are on investigating the properties of sinusoidal functions. And the first question asks us to consider the function f of theta equals sine of theta, where theta is between 0 and 720 degrees. So the first thing we want to do is create a table of values, that relates f of theta to theta. So remember, in the unit circle right here, x is always cosine and y is always sine only in the unit circle because the radius is 1. So if I were to create a table of values that relates f of theta to theta, I want to figure out what f of 0 is to start off with because it's from 0 to 720, and f of 0 would be sine of 0, which means what's the y value at 0 degrees? The y value is 0, okay? So if I were to make my chart right here, and I'm going to need to write pretty small because I've got a lot of values in my chart. So I've got theta and f of theta. When theta is 0, then the sine will be 0. When theta is 30 degrees, the sine will be 1/2. When theta is 45 degrees, the sine would be root 2 over 2, and I want to actually calculate root 2 over 2 so I have actual decimal values for that. So if I were to plug that into my calculator, I would get 0.707, okay? When theta is 60 degrees, the sine is root 3 over 2, so I would end up getting 0.866. When theta is 90 degrees, the sine is 1. So if you notice, as we go through this, the sine value is getting larger and larger and larger, and that's because the y value is getting larger and larger and larger. Then when I get to 120 degrees, the sine value is starting to get smaller because I'm going down lower and lower and lower for my y values. So when theta is 120 degrees, the y value, the sine value is root 3 over 2, which is 0.866. Let's just make a quick chart up here, not a chart, a quick note that 1/2 is 0.5, root 2 over 2 is approximately 0.707, and that root 3 over 2 is approximately 0.866. Okay? Then when I get to 135 degrees, right here, the sine, or the y value, is root 2 over 2, which is 0.707, okay? And then when I get to 150, the sine value is 1/2, or 0.5, and then when I get to 180, the sine value is 0. Now, when I get into my third quadrant, we know, according to the cast rule, that sine will be negative all the way until I get back to my starting point. So when x, or theta, is 210 degrees, the sine value is negative 0.5, okay? When theta is 225, the y value is negative 0.707, okay? When we get to 240 degrees, we know that our value is negative 0.866, okay? And then I'm just going to keep going around my unit circle, okay? So again, 240 would be negative 0.866. When I get to 270, my y value here is negative 1, okay? Then when I get to 300 degrees, the y value is negative root 3 over 2, or negative 0.866. When I get to 315 degrees, right here, the y value is negative root 2 over 2, or negative 0.707. And I'm just going to keep going. 330 is negative 1/2, and then 360 is going to bring me back to 0. So if you notice, my y values are increasing, reaches a maximum, decreases, starts going negative, reaches a minimum, and then increases back to my flat line again, okay? And hopefully that'll you'll start to see some connections between what we just talked about right now and the last video. If not, we'll get to that point, okay? Now, it said for us to do it between 0 and 720, and I went all the way around and I got to 360. How am I supposed to keep going? Well, because it's a unit circle, I'm allowed to keep going around and around and around. So one rotation was 360, and then up here, even though this is technically 30 degrees, it's also 390 degrees because it's 30 degrees more than a full rotation, which is 360. So I'm going to keep going with my chart right here, and I'm going to see right here, I'm going to have theta and f of theta, okay? And here, now I'm going to have 390 degrees. And at 390 degrees, my sine, or my y value, is 0.5, okay? At 45 degrees more than 360, which is 405 degrees, my sine is 0.707. At 60 degrees more than 360, or 420 degrees, my sine is root 3 over 2, or 0.866. Okay? And I'm just going to keep going. So at 90 degrees, which is 90 plus 360 would give me 450, I have a sine of 1. Okay? Then I'll end up getting to 480 degrees, which gives me a sine of 0.866. So that's right here. This part right here, add 360 onto that, and I'll be at 495. And the sine here is root 2 over 2, or 0.707. At this 150 degree angle right here, this would be 360 plus 150, so I would end up being at 510 degrees, and the sine here is 0.5. At 180 plus 360, I would end up being at 540 degrees, and the sine is 0. Okay, and I'm just going to keep making my way around. So next I'm going to end up at 570. And the sine is negative 0.5. And then I have 585 degrees, and the sine is, which is right here, the sine is negative 0.866. Over here, I'm at 240, add 360 onto that, and I would end up being at 600. And the sine is negative, sorry, the sine here is negative 0.707. Here, the sine is negative 866. And then here we'll be at 630, and the sine is negative 1. Okay? Here, it'll bring us to 660, and the sine is negative 0.866. Here, we'll be at 675, and the sine is negative 0.707. Here we'll be at 690 degrees, and the sine would be negative 0.5. And then lastly, at 720 degrees, the sine would be 0. Okay, so we have enough values here to be able to do a full, complete graph of what's happening here. So I'm going to set up my axes, and I'm going to put my x-axis right in the middle because I clearly am going above and below my x-axis by the same amount, okay? And then I'm going to put my y-axis here because all the theta values that we have here are positive. We'll talk about what to do if we've got negative theta values shortly, but for right now we'll just keep it like this, and I need to figure out how I want to space this out. So when I want to do this graph right here, I want to sort it out, or I want to space it out so that I go from 0 until 720 for theta, and then this right here is going to be f of theta, and that's going to be easy because my minimum is at negative 1 and my maximum is at positive 1. So I think I will just put negative 1 right here, and I will put positive 1 right here, so I know that this is a half and this is a half, so that's going to help me out. And I think if I go by 30 degrees for each block, then that will help me get to 720 degrees. So right here, I'm going to put 90 degrees because 30, 60, 90, okay, and then I'm going to do another 30, 60, 90, so this brings me to 180, another 90, so this will bring me to 270, and then another 90, and right here I'll be at 360. Okay, and then I'm going to do it again. So another 90 here, I get to 450. Another 90, I get to 540. Then another 90 will bring me to 630. And then my last set of 90 will bring me to 720. Okay, so now when I go ahead and graph this out, 0 degrees will have a sine of 0. Okay, 30 degrees will be 0.5. 45 degrees, which is halfway between 30 and 60 right here, will be 0.707. So I'll say it's a little bit over, or a little bit under the 3/4 mark. 60 degrees would be 0.866. And then 90 degrees would be 1. And this is where my peak is going to be. And then 120 degrees will be 0.866. 135 is 0.707, so it brings me back down right here so you can see the symmetry that's happening here. And then, 135 should be halfway between, so it should be over here. And then 150 is 0.5, and then 180 is going to bring me back to 0, okay? 210 brings me down to -1/2, so I'll put it right here. 225 will bring me to -0.707. Okay, 240 will bring me to -0.866. 270 will bring me to -1. Okay, and then I'm going to go back to 300 will give me -0.866. Okay, 315 will bring me to -0.707. 330 will bring us to 1/2, and then 360 will bring us to 0. Okay, and if you notice, we ended up getting a full wave, and that's because we went a full rotation around our unit circle. Okay, we still have to go up to 720 though, so I would like you to please pause the video and then graph out the remaining coordinates, and then we'll talk about what we need to do next. Okay. So if you notice, we end up getting the exact same wave right here. So when we connect the dots, this is what we end up getting for our sinusoidal wave that we have here, okay? So again, connect your dots, and then you'll end up getting your sinusoidal wave. Sorry, I'm having a little bit of a difficulty. So this is what we would end up getting right here. And then because our domain is from 0 to 720, we don't have arrows. But if there was no domain specified, then it would keep going forever and ever, okay? So based on that information, we're going to identify the key characteristics of f of theta equals sine of theta. So the first thing is I want to figure out what the period is. So how long it takes to complete a full wave, remember, is a period. So if you look right here, this is one full wave like this right here. So it would take 360 degrees to complete a full wave, which is exactly what we did in the unit circle. So our period is 360 degrees for a typical sine wave, okay? So that's one key piece of information. Another key piece of information is the axis, the equation of the axis. So remember, the axis is going to be the minimum plus the maximum divided by 2. So let's find the minimum. Our minimum value is when y is -1. Right here, this is the lowest it will go. And our maximum is when y is 1. So our axis is going to be y equals -1 plus 1 over 2, or just 0. So the equation for our axis is y equals 0. Our period is 360 degrees. Now, if I were to graph out the equation of the axis, this is where it would end up being. And if you notice right here, it's right down the middle of our sinusoidal graph. Okay, next I want to talk about what the amplitude is. So the amplitude is going to be just the distance between the axis to the max and the distance between the axis to the min. And remember, I can take the max and the min and subtract them and then divide it by 2. So 1 minus -1 divided by 2 ends up giving me 2 divided by 2, which is 1. So my amplitude right here is going to be, 1, and again, this is 1 from the axis to the peak, and it's also 1 from the axis to the minimum. Okay, the domain, if there is no restricted domain, then theta is allowed to be an element of the real numbers. Any real number I can plug in and find a corresponding y value. The range, however, has to be an element, sorry, we should say f of theta. F of theta is an element of the reals, but it's going to be between -1 and 1. So we're going to say -1 is less than or equal to f of theta is less than or equal to 1. Okay. And then the last thing that I want to say, so we'll just circle or box around all the key information that we have here. The last thing that I want to say is that the zeros, we want to find out where the zeros of our function are going to be. So the zeros, again, are where it crosses the x-axis. So the zeros happen at 0 degrees. We also have a zero that happens at 180 degrees. We also have one that happens at 360, then 540, then 720, so on and so forth. So our zeros will always happen at multiples of 180. So at 0 degrees, 180 degrees, 360 degrees, 540 degrees, so on and so forth. And that, again, should make sense to you going back to the unit circle because 0 degrees right here and 180 always happen on the x-axis. So 0 to 180 and then another 180 and then another 180, so on and so forth. Okay, question number 2 we are going to skip for right now, and I want to actually do this with you guys as a class. So don't worry about not finishing up number 2. We'll talk about it together as a class. So I just want to get the definition of a sinusoidal function down for you guys. So a sinusoidal function is still a periodic function, okay, whose graph looks like smooth, symmetrical waves. Where any portion of the wave can be horizontally translated onto another portion of the curve. Okay, so if you guys take a look right here, again, if I were to type in right here f of x equals sine of x, I end up getting my graph looking like this. Okay, and then if I were to do g of x equals cosine of x, if you notice they're the same wave, it's just it's been moved over. So the blue wave is the same wave as the red wave, it's just moved over. So those are both considered sinusoidal waves. Okay, but let's go back to the question that we have in front of us. So it says graph the function f of x equals 4 times sine of 3x plus 2 on a graphing calculator in degree mode. So f of x equals 4 sine of 3x plus 2, and we need to be in degree mode. So up here in Desmos, we need to click on the tool, and we need to change this to degrees. And we can barely see a curve right now because we're literally looking from negative 10 degrees to positive 10 degrees. So I'm going to change my x-axis so that it's, I don't know, between negative 720 and positive 720, just so I can get a better picture of it. And looking at it right now, it looks pretty crammed, so I'm going to make it a little bit smaller. So I'll do from negative 360 to positive 360 right here. Okay, so taking a look at my graph that I have here, I can still see my waves. Okay, and the first thing that we need to do is determine if it is sinusoidal or not, periodic or not first, and then whether or not it's sinusoidal. So it's definitely periodic because it's repeating the same graph over the same interval for x. So it's periodic, yes. And it's also sinusoidal because we have smooth symmetric waves. Okay, so we're going to say yes, it's periodic because it's repeating the same y values over the same interval. And then, yes, it's sinusoidal because it has smooth, symmetrical waves. Okay. Then it says from the graph, determine the period, the equation of the axis, the amplitude, and the range. Okay, so the period is the first thing I want to figure out. How long does it take to complete a full cycle? So to find the period, remember when it's sinusoidal, it's the wave is going to start in the middle between your minimum and your maximum. So here, this is the middle right here. It goes up to my max, it goes all the way down to my minimum, and then it brings me back to the midpoint right here, approximately at this spot right here. And when you look at it, it looks like it happens right when x is 120. So it takes 120 degrees to complete a full cycle. And then if I were to go back through another full cycle, it brings me to 240, which is another 120 degrees to create a second cycle. So that, therefore, I can conclude that my period is 120 degrees. Okay, now that I know what my period is, I can find the equation of my axis. To find the equation of my axis, I take my maximum and my minimum and I average them. So my maximum is 60, my minimum is -2, so I'm going to take 6 plus -2 divided by 2, that's what y is. So I end up getting 4 divided by 2, which is 2. So therefore, the equation of my axis is going to be y equals 2. And when I graph out y equals 2 on this graph right here, I can see right here that this is for sure going to be my axis right here, okay? And then the amplitude, to find the amplitude right here, we just need to figure out how much it takes to go from the axis to the max and the axis to the min. So the amplitude should be 4 because it goes from 2 to 6 and also from 2 to -2. So our amplitude is 4. But we can calculate it by subtracting our min and our max and then dividing by 2. So 6 minus -2 divided by 2. So I get 8 over 2, which is 4. So my amplitude is 4. And then my range is going to be f of x is an element of the reals. And my range is going to go from my lowest value, which is -2, to my highest value, which is 6. So I'm going to say -2 is less than or equal to f of x is less than or equal to +6. Okay, now one thing I want you to think about before I see you guys next in class is where did this equation come from in regards to the original function? Okay, where did the period come from, and where did this amplitude of 4 come from? Okay, all right, question C asks us to find f of 20. So to find f of 20, I literally plug 20 in for x. So f of 20 is going to equal 4 right here times the sine of 3 times 20 plus 2. Okay, so I end up getting 4 times the sine of 60 degrees plus 2. So here I'm going to do 4 times the sine of 60. I know that the sine of 60 is √3 over 2. So I'm going to say 4 times √3 over 2 plus 2. But I also know that this 4 and this 2 will reduce to a 1 and a 2. So I end up getting 2 √3 plus 2. Okay, now let's figure out what this is as an exact answer. So I'm going to take 2, multiply it by the square root of 3, and then I'm going to add 2 to it, and I end up getting about 5.46. So this is equal to approximately 5.46. Last thing I'm going to do is type that in. I'm going to figure out what f of 20 is, and we got 5.46, which is the correct answer. So that's how you evaluate certain degree measurements in our function right here. Okay? All right, that's it. Let me know if you have any questions, and I hope you have a great day. Bye.